All right, let's go ahead and get started here. Welcome everyone. Very happy to see you all here. We're going to be discussing today actionability in smart buildings, an area very near to my heart. And so as this session goes on, we're hoping to get the different moderator or the different panelists involved in discussing not just what kind of analyses are happening, but how we're taking these analyses, these different pieces of software, and making them useful practically to users in the field. So just a brief introduction for myself. My name is Trevor Sodoroff. I represent a company called DB Engineering based out of Redmond. I've spent the past decade essentially trying to turn data into action, and so I'm very excited to be here. For all of you that are attending, please feel free to drop any questions or comments that you have into the QA box, and we'll try and moderate or watch those as the session goes on and make sure that if any interesting ones come up that we get them into the queue and maybe have some of the gentlemen on this call give them an answer. So today, we really want to focus on actionability in smart building technology, particularly in analytics. Over the past decade, we've seen the industry really ramp up the hype machine with respect to smart building technology, but I think everyone here still has an intuitive understanding that not everything has gone as smoothly as maybe it says in the sales literature. Right? So we have a problem with taking things that are being identified in buildings and actioning them. And this is a problem because of scale. It's a problem because of the way in which prioritization is made. It's a problem for a number of different reasons. And so what we'll want to do during this session is really discuss why that's the case, how we got here, how we're moving out from just being able to identify things to being able to action things, and really what works and what doesn't, and what the future may hold for us over the short and the longer term. So I'd like to introduce the panelists real quick. We're going to have each one of them give a little brief introduction to themselves and to their the companies that they represent. So we've got Pete Segall. He represents ATS Automation. I've got Saeid Ansari here with EllisDon, Troy Harvey with PassiveLogic, and Gabe Sandoval with UCSF. So I think we'll just start off with you, Pete. Without any further ado, jump in. Please give us an introduction, what you do, and let's go from there.
All right. Hi there, everyone. My name is Pete Segall. I'm the Energy Services Manager with ATS Automation. I've been in the building automation and energy management and energy efficiency industry for 26 years, the last 23 of them coming at ATS Automation. At our core, ATS Automation, we're a building automation, energy management system contractor and service provider. My focus is a little bit different from that. I run our energy services department, and really we have two primary functions out of that department. First, we are a Washington State registered ESCO. We provide energy services, performance contracting in both the public and private sectors. But also the secondary kind of division within my group is we have a building performance and analytics team. And really what that team does is it provides commissioning and M&B services for our ESCO projects. And we deploy and heavily leverage analytic tools for both the commissioning and the measurement and verification of those projects. Additionally, our building performance and analytics team, they also use analytics really heavily for just standard traditional services we provide to customers, be that things like benchmarking or building tune-ups or existing building commissioning and things of that nature. So really what we have tried to do as we have grown is try to have commissioning as part of our projects and part of our services, and one kind of rolls right into the other as well. So that is me. And did you want me to just roll right in now, Trevor, and start sharing? Okay.
Please roll right in.
Okay, let me see if I can do the screen share then. All right, hold on. And in full disclosure for everyone, and we'll see how much you really should listen to me to see if I can do the screen share. I am giving this presentation from my bed because I, as my wife likes to say, am an idiot who doesn't really understand expectations sometimes, which I think sometimes maybe it could be a theme throughout this discussion as far as setting expectations. And I forget that I'm a 48-year-old man who doesn't bend very well. So I'm dealing with some injuries right now. So does everyone see my screen?
Yes, sir.
All right. So I've done a lot of these conferences. I've attended a lot of these conferences. I've spoken at a number of these conferences. And I feel like sometimes when we talk about case studies, because that's what I'm going to start with, and we're all going to talk a little bit about case studies, really talking about these case studies is this opportunity for people kind of like me to kind of pat ourselves on the back, talk about what amazing work we've done, and really show this kind of perfection of projects. However, in general, I kind of see these conferences, they're kind of like LinkedIn, they're kind of like Facebook. It's we were giving you this perfectly curated content to the outside world, talking about how great things are, but not telling you the real story, what's behind, what's behind the scenes, the chaos, the imperfection, the problems that we run into on projects, on most normal projects. So instead of just giving you a case study on how great we are, because you can't really learn much out of that, the case study that I want to talk about is actually a compare and contrast of two projects, and one that I would consider successful and one that I would consider a failure, because I think we learn even more about how to progress if we kind of pay attention to our failures. So that's what I want to talk about today. Let's see, how do I move the slide forward here? Okay, so today what I'm going to give a quick overview, 7 minutes maybe tops. It's what I'm calling a tale of two analytic deployments. It was the best of projects, it was the worst of projects, which is something that Charles Dickens definitely never said. So the two projects I'm going to talk about, Project A, it was a monstrous project. It was a well thought out project. There was a goal behind the project. There was proper funding. It was 340 buildings, over 11 million square feet. Really interesting project and something that we learned a lot on. And then Project B, the complete other end of the spectrum. It was one building. It was 8 stories, 150,000 square feet of office space, 150,000 square feet of parking, traditional Class A office, mixed use, restaurant, etc. And one of the main reasons I want to talk about these two different ends of the spectrum is that all too often, when you also come to conferences like these, you hear people talk about this amazing project that was done on this huge campus and they spent millions of dollars on. And then sometimes, the majority of the buildings and the majority of the people that are probably out in the ether land right now, they're like, hey, I don't have millions of square feet. I have 2 buildings. I have 3 buildings. I have a small campus. Is what you're talking about scalable to people like me? And that's what I want to show here, is that analytics can be used in large scale regions of buildings, or it can be used on individual buildings, and it is scalable. So let's talk about the who and the why. Project A, there was an analytics champion. This person had a brilliant vision of what they wanted the future of managing, operating, servicing these buildings look like. They had 340 buildings over, I don't know how many hundreds of square miles, and managing that is very difficult. So analytics was going to be the kind of the cornerstone of how they were going to operate these buildings. Project B, we had a pretty engaged property manager. She knew there was issues. The building only opened up in like 2017 fully. The hot and cold calls were kind of increasing over time, and their utility bills were increasing over time. They knew they had an issue, but she wasn't really sure what to do with that. So how did we go about deploying? How did it get funded, if you will, maybe? Well, on Project A, it was a plan and spec project, a very large project with, there was a large controls upgrade and analytics piece tied to it. Project B, well, it's like, well, let's tailor it to what it should be. And it was a service offering that we provided them. Project A had a really detailed analytics platform and deployment specification down to the details, even, had, expectations of rules and fault detection and things of that nature. And it was just a single deployment contract. Bring in all these buildings, deploy the rules, the fault detection, and that's the project. Project B, we just created a small tailored analytic deployment, multi-year service agreement with monthly team meetings saying, hey, let's how we'll go about solving this nut that we're dealing with. And then the who in Project A had a pretty fully staffed facilities organization that supported the entire region. Granted, no matter how, I use the term fully staffed, and we all know there isn't enough staff to manage buildings, especially that are spread out this far, but they had a lot of people supporting these facilities. Project B, they had a single on-prem engineer. Engineer may be a stretch because he had to do a lot of different things, wear a lot of different hats, but they relied heavily on their service partners for mechanical service, control services, and others, and how to support the building. So, as you're kind of looking at these two projects, you would say, wow, these are very, very different projects, but they still have the same kind of goals and outcomes in some respects. So some of the outcomes we saw, Project A, we had a really successful analytics and FDD deployment. We had this great software package platform, data was flowing, solid quality data across 340 buildings. Yeah, I would call that a success. Project B, hey, we had a successful analytics FDD deployment as well, just at a much smaller scale. Project A, that analytics champion we had, well, he transferred. Near the end, before the project was complete, this person transferred to another region and they never instituted another analytics champion. So the vision that this person had, the plan that this person had to use all this data, all this information, kind of went by the wayside. Project B, we just kind of continued moving on with monthly team meetings, not getting super deep, but we really just focused on comfort, energy, and general building performance. We were just looking for real basic stuff. That was low cost, no cost solutions. I call the 3 S's of controls. It's set points, sequences, and schedules. Really focused on that, finding issues, problems, things that they weren't finding typically until they'd get a hot and cold call or a change in the season. And then also we'd identify some capital measures here and there for future planning. And so when it was all said and done, the outcome of this Project B, because I had really nothing to talk about Project A, was this was a building that when fully occupied in 2017, the lowest EUI the building had was around 106, 105. We got involved in 2019, it was about 105. Even through COVID, 24-hour operations, 100% outside air, doing what they could to make sure they felt their people were safe. We now brought the EUI down by about 20%, and their hot and cold calls really reduced. And I know as I'm talking about this, I'm talking about a really simple building. But I think it's important to realize, and when you hear these case studies, you hear these amazing case studies about these campuses and these high-tech campuses or data centers or college campuses. Everything we're talking about today can be distilled down at smaller levels at individual buildings. So I want people to, one of their takeaways to be that. But the second takeaway, and this is what we'll really be talking about today. Oh, and sorry, I'm going to back up. Is trying to understand why some of these projects are successful and why some of them fail. So when I kind of broke down these two projects, looking at Project A, well, we used a certain software set on Project A, and we used that same software set on Project B. We used a lot of standard and custom rule sets on Project A. We used a lot of standard and custom rule sets on Project B. So effectively, from a technology standpoint, they were the same project. Yes, scale was much different, but from a technology, very similar. The deployment was simply in Project A, they say, just give us the software platform. You develop it, you do the integration, you bring the rules together, and you hand it over. Okay, good. Project B, similar thing, except for there was a service piece tied to it. Project A, well, we had a visionary and a champion, but they became absent at the end. Project B, we had a relatively engaged project manager. Project A was the change management. There was absolutely none done, because if it was done properly ahead of time, that team that they had behind this analytics champion, this facilities team that oversaw the region, they probably would have had a plan in place. In Project B, there wasn't a whole lot of change management involved. However, because they outsourced everything, they kind of turned to their outside contractors to run this ongoing analytics project. So my general takeaway, and I think the theme that we'll be talking a lot about today, and I'm just, without even saying it, this is really how I see it. Technology is really the engine that makes these projects possible. We wouldn't be doing this if we didn't have the technology, because it would just be too cumbersome. We can do small bits of it, but not to the extent that we're doing. But it really does come down to the people, the processes that you use, the planning you put in place, and setting those proper expectations of why you're doing this, that really makes these projects successful. So I think that's going to be kind of the theme maybe that happens today. I haven't talked to anyone else too much about that, so hopefully I'm not stealing too much thunder, but that's kind of my takeaway when looking at two majorly different projects using similar technologies with wildly different results. So thank you.
Thanks a lot, Pete. We'll have a couple of follow-up questions for you, I'm sure, as soon as we get through these introductions. Let's move next to Gabe. Gabe, you want to go ahead and introduce yourself?
Sure, thank you. Yeah, my name is Gabriel Sandoval. I'm a senior controls and commissioning engineer for UCSF Health. So UCSF Health is, we have 3 major hospitals plus quite a bit of MOBs as well. In my role, I serve as the primary point of contact for all the automation systems. So I support all the current systems on campus, but I'm also involved in planning for projects, for design of the projects for the control systems, specifications, the commissioning as well. I'm part of a team, the energy and utilities team. So our focus is reducing energy and our carbon footprint as well. And so quite a bit, we talk about deploy analytics, fault diagnostic detection as well. I'm going to share my screen here. So primarily what I wanted to focus on is not so much case studies of some things that I've worked on, and I've been part of, used analytics for commissioning for quite a number of years. I've really started getting involved in this probably going back to, I don't know, 2015, 2016. So I've been a big supporter of it. I'm one of those champions as Pete was talking about. But focusing primarily on this new project we have. So we have a new hospital that's being built at UCSF. We term it or coined it as NHPH, New Hospital Parnassus Heights. It's going to be a challenging project with a few reasons. Again, I'm condensing this down. There's a lot of challenges involved in this, but it's an 800,000 or 900,000 square foot hospital. So it's a rather large hospital that's going to be built. It's a complex project, as most hospitals are, right? There's a lot of new technology that's going to be involved with it. And then obviously, with all the things involved within hospital ORs and ISO rooms and, so on and so forth. So it's a very complex project. But one of the bigger challenges for me in this project is the timeline. So because of its location, it's going to be built in a built-up area of San Francisco near the Golden Gate Park. It's going to take a long time for this project to be built. So we're not estimating the completion time to 2030. So when you think about that, and this has been something that we've discussed as a team quite a bit, where is the technology going to be at 2030? I mean, think back 7 years ago compared to where we are now, and then try to now forecast where we're going to be at in 2030. So that is a challenge that we're facing, and it gets difficult because the project team, if you've been a part of construction projects, they want you to make decisions now because they have to set their budget and they have to start designing. And so as much as possible, we try to hold them off on some of these decisions. But again, this is a challenge to think, well, what's this going to look like? What's BMS going to look like in 2030? What's front end analytics? What's all they're going to look like by 2030? So I won't get into all that stuff because I could talk about all that, but primarily focus on data analytics. How is this going to be deployed, used as part of this project, both during construction and then post construction? So again, as I mentioned, I've been using analytics, been a supporter of analytics for commissioning. There's this term, connected building commissioning. I'm sure most of us might be familiar with it if we've used this and been a part of it as well, where we use analytics as part of commissioning. So through the process, generally what we do is write an RFQ and we specify, a certain analytics software package as part of this commissioning that needs to happen. Part of this RFQ, we want the software to be on-prem. We have a version that will run on our servers, and then they will work on our servers to build out the analytics and FTD. And then the idea is that this will then be turned over to us, right? So the benefit is the building gets commissioned, and then all those FTD rules, analytics carry on, and then we get to use it as an owner. So how's that worked out? Well, I think it's been good. I mean, I could go through quite a few projects to where having the analytics deployed and having all that data trends easily available has helped us work through some issues that we've had with projects, towards the end and towards closeout and turnover. So I think overall the effects have been positive, but there has been some lessons learned that I've picked up out of this. One is when we go out to put out this RFQ, what I found is that there seems to be very few commissioning agents that know how to use the software we specify. So what usually happens is we get either very few interested, or the commissioning agents that are interested that don't have somebody in-house, they have to go out and then bring somebody in to support them. So not an ideal situation. You know, we want to have a good selection of commissioning agents to be interested in our projects. And then secondly, I think as mentioned, and we're probably going to talk about quite a bit more, once this software gets turned over and all of this work that's been done to build out the analytics and the FDD, nobody winds up using it. Or, you know, it's very few people that wind up looking at it. So again, something that I've learned coming out of these projects. So I think, and this is the part I want to focus on, for me, this is the one thing I think I'm coming to realize and learning is that I think the mistake may be focusing in on one software application. Don't focus in on that, but rather focus in on the ability that other ones can use their applications. And then allow the data to be actionable at that point. So what do I mean by that? So I put together this kind of simple diagram. So, and again, I put this together very quickly, so excuse my graphics. I'm not really good at building this stuff. So when I've been here at UCSF for about a year and a half. Before I was a manager of the controls at Stanford. I managed the technical team at Stanford. And so we had began building out a data lake, which I think now, you know, they're terming it as an IDL. So we started building that out back there when I was at Stanford. And, you know, we brought in various data from building systems. Again, I didn't list, you know, there's 20 million square foot at Stanford. So we had data coming in all these different ways. So we started building this out there. It was kind of a haystack-ish model, as I say. It's kind of uses haystack, but we had to develop kind of our own ontology and built on top of that to expand it out. It's an on-prem server, and it could also support some fault diagnostic detection and analytics. So after a short time, we had another department come to us and say, hey, we want to use our own cloud-based fault diagnostic detection. And at first we were like, well, hey, we've got something on-prem already. Why don't you use our system? No, we want to use this cloud-based. And they had reasons, and they were good reasons, they're valid. So then we came to as we were going through this, we were discussing, well, do we want them to connect to our building systems, or do we want them, how do we want to handle this? So at first we started having them connect to our building systems, but there's technical challenges that go along with that. And you know, I don't get too much into that, but you know, when you start pulling data from multiple systems, start pulling data from one server or controllers, you can come across some issues. So then we said, well, hey, why don't you pull from our data lake or our IDL? You know, we support a Haystack API connection, pull from that. So we worked with them, made the connection, worked great. It wound up being a really easy thing to maintain and support long-term. The second thing that happened too is we had this PhD program happen. It's called Cooler. It was, in a nutshell, just some PhD students that they're part of the energy department that were doing research into buildings and how to reduce energy. And so they wanted to do they wanted the data. So again, went through the same process. Do we have them pull data directly from the BMS? Or at this point, we had our data lake fully up and running, and we already supported this other way. We say, do you use our data lake? So I had them connect to both and to tell me what they preferred. Well, they preferred coming through the data lake. So they used the PyHaystack connection. They said it was much easier. They can understand the data. We had our model, our ontology, you know, documented. So we just handed them that document, and then they were able to figure it out. So and then one other thing I'll add to that also is, you know, we were also able to support some read-write capability as well, which I thought was interesting. So we got to talk to them about running test scripts. So this was right when COVID happened and buildings were empty. And so we were able to turn whole buildings over to them, and they were running test scripts and making set point changes. And so it wound up being a really cool way of allowing them to be able to interface with our systems, but in a way that we felt like was very supportable. But long story short, I think what I learned about this is, instead of pushing the application, the software application that we're using, it started making me think that, hey, maybe we need to start more focusing in on allowing the data to be easily accessible so that then they can build on top of it. So bringing that back to the NHPH project, you know, we know we're going to have a building management systems, right? That's going to happen in the building. We have our on-prem software that we're going to always have and need, but instead of focusing in on pushing that data during the project into that software application and then forcing our commissioning agent to use it, what we're going to focus in on is building out this, well, what now I think the term is independent data layer. There's a lot of things that I learned in terms of some of the technical things that I think we'd like to have out of it. And we're working with another software vendor to look at doing that. But I think, we're going to be looking at bringing in BMS data, bringing asset data, modeling this data. And then at that point, whatever software that the commissioning agent wants to use, and again, thinking 5, 6, 7 years, and there might be some other really cool, powerful software that could be out there. We just want to support that. So instead of forcing them to use one software, again, let them use what they feel will make them best at their work, which in this case is the commissioning agent. On top of that, again, we'll still be pulling data into our systems. We can do our analysis. Front-end digital twin, is that going to be a possibility by then? I think that more and more, I think we're seeing that could be a possibility then. Will we need a front-end on-prem? I don't know if we will. I feel like more and more, I think we're seeing the benefit of pushing things out to the cloud, and I think that's going to affect front end as well. But again, then going back to with this independent data layer, I think then we're going to be able to allow other departments, facilities, whoever else, be able to use this data. So if the facility has another application that they want to use, fine, we'll support that. Other departments within UCSF Health, pharmacy, whoever else, if they want data pulled out of it, we'll be able to support that. So I think, again, it's really looking at what's the best way to make data actionable and support analytics. I feel like this is a better route for us to focus on long term. Anyway, that's all I got.
Cool. Thank you very much, Gabe. Cool. And now, for those of you that are asking questions, Gabe, I think you've got a question in the Q&A section. If you want to go ahead and answer that during the next little session, otherwise, we'll get that into the questions for later in the session. So let's move on. Troy, let's go with you next.
Awesome. So I'm Troy Harvey. I'm the CEO of PassiveLogic. And really, PassiveLogic, what we're doing is, we're taking all these things that we've heard in the last 20 minutes into account and saying, boy, how would we reinvent this whole approach to how we design, build, operate, commission, manage buildings? And when we first went out to venture capital in our early days and said, hey, buildings, we're gonna reinvent buildings. They're like, buildings, what are you talking about? And we're like, buildings, 25% of world GDP, buildings. And at first they didn't really get it. And we really had to teach the thesis of why buildings were important. And what I think is exciting about today is that, we as a company really reinventing how we think about buildings are now backed by top 10 technology venture capital, big building companies like Brookfield, as well as partners like NVIDIA and Pacific Northwest National Labs. So it's been a fun process of getting people on board to, what does the future of buildings look like? And I think Gabe and Pete really kind of laid out some of the challenges that we had. So what I want to do is walk us through the paradigm shift that we're talking about here at PassiveLogic, and I think that's best done with a little bit of a deck here. So what we're interested in is full autonomy, and how full autonomy as a new platform for the way we think about our process from the beginning of the design process through the management of buildings can enable a new workflow. And the way that we think of this workflow is let's start with, I think Pete set this up as people, process, and planning, right? Like, how do we enable that so we're not here in these meetings years from now still having statistically oriented slideshows around ROIs that we can maybe just barely prove. And instead, we're like, hey, we won on the first day, right? Our whole team was more effective, working together, and we had tools that were built for us, not just given to us to use. And I think that's a lot of what we see in the industry is we are the recipients of the downstream as opposed to that we own our own power with tools that were built for us. So first, what does this mean, fully autonomous building? So what we mean by this, and I'll walk you through it in more detail, but self-serve autonomy. Any application, whether we're talking about HVAC systems, energy systems, process control, industrial, all these things in and around buildings, that's our interest. And I'll walk you through this just briefly. So in PassiveLogic, you can just draw or import BEM. You can scan your building with an augmented reality tool and generate these digital twins of buildings. Drag and drop your IoT and sensors into that, design what your systems you're going to be controlling, customize those behaviors. We automatically generate the control systems and provide automatic point mapping, give you the ability to translate between all the different protocols so we're not down in the protocol stack. Really change the way that BMS works so that we have more of a plug and play system that's continuous from that design to interactive wiring that's checking your wiring, making sure your guys are doing it right in the field. Provisioning those sensors, locating them in the building, and automating this commissioning process. This is all around digital twins, so we'll be talking about that a bit more. But with this, we're able to really enable this control autopilot, and not just analytics, but analysis, how and why. And then finally, we were just talking about data lakes. We think that there's this fundamental problem today in the industry, in that we're basically all working way down in the network stack, and there's like literally no abstractions. We're really programming in the computer science equivalent of the 70s in the building market, and we have all this data streaming into data lakes, and the data scientist has become the 2022 equivalent of the coal miner, trying to find these points of value in these giant seas of data. And so how do we turn that into real value that's ontologically meaningful, that we're not down in the network stack, and we're actually talking in real terms at a high level of abstraction? So that's an introduction. So I want to take you through, what are autonomous buildings? What does that mean? First, I think it's worthwhile to recognize we work on the most complex robots in the world. Buildings are nothing more than these giant stationary robots with thousands of sensors, hundreds of control points. And if you compare that to anything else people make, say a robot on a factory floor, it has 6 axes, right? 6 degrees of freedom. We're talking about thousands of degrees of freedom in a building. And that's a mid-scale building, right? You have projects very readily in large-scale buildings that hit 1 million I/O points. And that's unlike anything else people make, right? An autonomous vehicle is 50 to 100 sensors and 3 controllables that can steer, brake, and accelerate. So I think if we start recognizing buildings for what they are, these really complex projects, and understanding that the end point of all these markets, it doesn't matter what kind of controlled infrastructure we're talking about, is full autonomy. And given that buildings are the single largest infrastructure for controls in the world, let's go do something about it, because this is a big market. It's worth really investing in. So the biggest problem we see is today's quote unquote smart buildings is a euphemism, right? It never actually means smart buildings. Nobody in this room's seen a smart building. What you've seen is connected buildings. And generally speaking, this is one-to-one mapping between one device and its cloud, or you stream it all to a data lake, which now that implies exactly the problem, right? Like you've just got this pool of data with no meaning. So what we see, though, of course, is that buildings are getting more complicated than that. That's where we're starting from, thousands to hundreds of thousands of I/O points, maybe even 1 million. But what we're being asked to do is getting more complex. And what we're lacking is really the organizational intelligence. None of us are hired to commission a building. None of us are hired to program a set of sequences. What we're hired is to make buildings go, right? What people want is action. And so long as we're all stuck with a man in the middle problem, we're never solving the actual core root issue. So here's where we see the market today. You got 2 markets. You've got the market above 100,000 square feet where BMS sucks, and the market below 100,000 feet that doesn't have BMS at all, right? And that's really our core problem. So unless we can make scalable solutions, and I think, again, Pete set this up very well, like how do we make things practical and scalable? How can you apply something to every project? And how can you make sure that all of the guys in your field team can do it? And how can, as Gabe was bringing up, how can we leave something in place that the operations team's actually going to use? So let's talk about what smart buildings are, because I think if we have a framework, it's better to understand what we're all talking about. So in the vehicle world, we've come up with levels of autonomy, and it turns out they apply right to buildings. So level 0, that's algorithmic control, that's manual control, that's cruise control in a car, that's set points in a building, right? So cruise control set at 60 miles an hour, building set at 72 degrees. In fact, both these are most likely going to be PID driving each of them. Level 1 autonomy in a vehicle is adaptive cruise control. You're going 60 miles an hour, you come by a slow car, your car slows down, that car gets out of the way, your car speeds back up. In the building market, this is what we see largely as the market edge. You still have dumb controls in your building. You might attach some kind of algorithmic or AI or model predictive control in the cloud. It tweaks and tunes and adjusts your set points, but it's never going to be more than the controls underneath it. So what we're really interested at PassiveLogic is full autonomy. This is just like in a car, where a car navigates from point A to point B in a two-dimensional map. In a building, we're not moving in space, but we're moving in time. So we're looking down that tunnel of time. And instead of 2 dimensions, we actually have this much more complex fleet of subsystems that we're navigating all together in coordination through that multidimensional space. Turns out it's exactly the same problem. It's route finding. What is the best control route of these millions of paths you could take with forks and turns and on-ramps and off-ramps? But what's interesting about buildings is we have more opportunities than the vehicle market. In vehicles, level 5's the max. Vehicles aren't going to make themselves in the factory. But in buildings, in fact, this is the bigger opportunity. We think that smart buildings is great for operations. It's crucial. But what's maybe more important is how do we use that intelligence to get them installed right the first time? How do we guide their own install and commissioning? And I think when we look at this in terms of our marketplace and the realization that buildings are these giant robots, herein lies the problem, right? We have all these traditional solutions. They're not going to evolve out of level 1. There's just no way. You can't get it to level 2 or 3 without throwing it all away and starting over. And the net complexity that we're dealing with is the cause of our problems. So let's like kind of just break that down momentarily. You know, what we see as the core of all this is controls don't know buildings. When I hired my VP of software who came from the tech industry, and I told him that you can buy a $1 million or multi-million-dollar control system and there's nothing in that control system that knows anything about buildings, I blew his mind. Right? Like that's the state of the buildings industry. It's not other technology industries' state. So what's the core problem here, right? So we're doing manual programming, manual equipment discovery and wire up, manual commissioning, and nowhere in this whole thing is actually what it's doing, right? And so when we look at this programmatically, we call this black box programming. There's no embedded knowledge in the system. It's not introspectable. You can't like pull it apart and see, why did Fred do this 5 years ago? You don't know. There's no inference, meaning if there's a sensor in the boiler and a sensor in the buffer tank, you can't tell anything about the pump in the middle or the pipes or the heat exchangers. You can't infer anything. And it's fundamentally not optimizable. And I know some people might say, hey, we optimize these things all the time. And having done quite a lot of building energy engineering work, I can say that we know where buildings could be, and we know where buildings actually are. And I think you can throw a lot of labor and a lot of dollars, but you never actually get there in terms of what's possible. So here's what we think is the core problem. Buildings start with all the information, they lose it all on the way. So the client's like, I got this building idea, and the architect's got a big vision for the building, goes through the whole process as it goes down the pipeline of all the different trades, and finally ends up in our hands. At the end of the day, what always happens is the client's pissed, right? And we go in circles and loops of trying to make this better, but the problem was all the information, and we'll talk about this in terms of digital twins later, was lost from its initial intent to what are we having to manage from the building's control system. So let me walk you through.
Troy? Can you all hear me?
I can hear you, Trevor, but I
Perfect.
cannot hear
Okay.
Troy.
Well, it looks like we might have lost Troy. We might have to get into this discussion a little bit later in terms of the new workflow. In fact, that will be part of what we're going to be discussing during the group session.
Can you hear me any better now? Does this work?
Yeah, I can still hear you. You want to give a 30 seconds wrap up here, Troy?
Yeah, I'll just give you a wrap up. How we see this market is build it from digital twins in the first place. Use a workflow of tools that allow you to have a building digital twin perspective instead of a controls programming perspective. So design your buildings, whether that's scanning, importing CAD, BIM, design your systems. From that, we're providing all the physics underpinnings to enable the end user to make sure that wiring's done correctly, automating commissioning, giving us real commissioning tools, both at the controls and at the edge, and then putting that on a new platform that knows how to control the buildings around those digital twins, and then providing that to be truly autonomous, meaning this can't be cloud connected. We don't have enough resiliency. And then at the end of the day, that we get things like analysis and analytics for free, not as a extra bit of work. So that's how we see things at PassiveLogic coming together for the future to address these issues that we're all juggling today in the marketplace.
Cool. Thank you very much. We'll definitely have some things to follow up on there. Saeid, you want to round us off here?
Sure. And hey everyone, I'm Saeid Ansari. I work for a construction management company in British Columbia called EllisDon. We are the first or second largest constructors in Canada, and we primarily work on complex buildings and hospitals and healthcare projects. My role here is the Building Performance and Commissioning Director, and I oversee all the BC and Western Canada projects with that aspect, focusing on making sure the projects, finish properly and they plan properly. And there's a consideration for commissioning and building performance. I wanted to share one of our projects with you guys. Just see if I can start sharing this. And essentially, this is, see if this works. Okay, perfect. So this is the healthcare project that we have in the interior region of British Columbia. Now, the funny thing about this is that this project was not a smart building. It wasn't designed to have any analytics. This was not planned. There was no budget for this, which made it extra fun. And we didn't have anyone especially looking at this and making sure it's part of the commissioning process. What we did have was that as part of our project agreement, we had an energy target that we had to either meet or beat. And part of us generally discussing internally, trying to figure out how we can do this, we decided to take a risk and start using analytics on this portion. What we wanted to do was we wanted to make sure that we have something in place to flag anything that would impact our energy consumption, any manual overrides, any set points that are changed. If there are equipments that fail, meters that are not calibrated, we get disconnected. We don't wait 2 years down the line to figure out that something's been operating for 2 years and we're using energy and we haven't figured this out. And the last one here, I wasn't really expecting to find anything here because, like I said, this wasn't planned. And, by the time we actually implemented this, the building was fully commissioned and it was balanced and it was completely handed over. But we want to find any efficiencies that we can implement in terms of sequences and getting making the building operate better in terms of what we were looking for. So essentially we were just being a regular contractor trying to save money here. We didn't have any grand visions of handing the amazing product to the owner. This was primarily for our own benefit, not to get penalized on energy targets. We surprisingly found out a lot of things that I was kind of not expecting, but we saw some fascinating items here. One of the first things that our consultant here, actually, I got to mention this. This is a point that Gabe brought up in terms of finding the right consultant. We quickly realized that our commissioning authority doesn't have the capabilities to use data analytics to go through and complete the task that we're looking for. So we reached out to a company in Alberta, DB Technologies, and they quickly set up this whole process for us. We didn't go with a specific vendor. Everything was open source. We just we bought a server, connected it to the network, pulled in the data, and started writing faults and just doing bare basic analytics using Power BI. So everything was stock. Nothing was purchased through any cloud or anything like that. And one of the first things that DB Technologies found for us was when they looked at the hot water system, they quickly realized that, hey, your performance is way off. The building was designed to have a delta T of 18 degrees. You're operating around 6 degrees. What's going on here? And this was kind of interesting because I knew things were going to get missed. I was also a commissioning agent when I started out my career, and I knew like you can't commission a complex heating water system in 2-3 hours and say everything's working out, but I wasn't expecting this. What we ended up figuring out was that the internal sequence for our boiler controllers were not set up as designed. Instead of getting a variable flow system that can reduce the pump flows as much as possible and give us the greatest delta T, we had a boiler system that was operating based on stages. So the pumps were running 30, 60, 100%, and that's it. And this was completely missed. And I don't blame the commissioning agent because, like I said, this is not something that you can analyze in 2-3 hours on site when you're doing functional testing. You need weeks and even sometimes months of data just to be able to see how the whole system's working out. But this was one of our biggest wins that I think 4 months after this got flagged, our energy modeler brought up an email saying that, hey, your boiler efficiency isn't where we expected it to be. So I was very thankful that we had a plan and we're addressing this right now. The next item that we had was that my biggest fear overrides. So our building operators, there was an issue with our cooling towers in this hospital, and what they did was that they put on a manual override just to try to address it. But then, as usual, there was another fire, and everyone wants to put that out, and they forget about it. And it's completely normal, happens all the time. But luckily with this, we were able to flag it within a week's worth of time, and we didn't have this operating for 2 months, using up all those energies and getting penalized for it. The second one was the biggest concern I had is that we had an incorrect differential pressure set point set up on our chilled water side. So what actually ended up happening was that when the balancer was working with our controls contractor, they were communicating over phone or radio, and they set up the reading, they took it, and they told them, all right, set this at 8 PSI. It's like, all right, perfect. We're going to put it in there. And they put it at a wrong location. So we had the pumps controlling to a significantly higher pressure. And the only way we realized this was that we were looking at our valve operation and it didn't make sense. It wasn't lining up. It wasn't being as efficient. And after a couple of rounds of meetings and talking with people and trying to figure out, what we found out is that, yeah, they just miscommunicated with each other. And this was one of our biggest issues. And the last item was failed differential pressure sensor. So this is, again, a brand new building, fully commissioned, but one of our sensors had failed. And we had our 2 chilled water pumps running at 100% all the time until that got replaced. The other issues that we had when the team looked at the air systems, these were a little bit surprising because, as I said, this building was a fully commissioned building. And we were expecting this to be, these type of issues not to be found. But we found out that our preheat valve operation had a safety program during construction just to make sure the coils don't freeze. It's normal, it makes sense, but no one flagged it and it got completely missed and it got handed over to the owner with this program. So using analytics, this was kind of came up that, hey, this operation doesn't add up. Why are your valves operating abnormally? And we were able to just delete that program, fix it. We have a heat recovery chiller in this building, and what we have is a sequences just to create load and extract as much heat as possible. But our cooling valve operation wasn't set up to work properly with our heat wheels. So during the testing, because it was done in winter time, no one really looked at the cooling valve operation, and we found out that instead of modulating your heat wheels and getting as much heat transfer as possible, we were opening our cooling valves 100% of the time. We're not even achieving any energy savings from our heat recovery chiller because the sequence isn't properly optimized in between. And this last one is also tied into the same point, is that the economizer operation, kind of the basic points of commissioning, wasn't properly set up with your heat recovery chiller. So it wasn't set up to give us as much heat extraction as possible. So kind of the opposite issue as our second point. And we found these issues, and I kind of assumed these would be the basic parts of what we could have found out during our air systems, but kind of surprised, because when we went deeper into our floor operation, we quickly realized that there are major issues. Our handling unit supply air temperature was locked at 17 degrees. Our VAVs were trying to cool down the space or trying to discharge 13 degrees supply air. So kind of creating cooling out of nothing with no coils. Again, this creates a part of the issues that happens where the systems are not looked at together. They're looked at individually. There's a specific checklist, and you just try to go through that checklist. Or sometimes you even do a random sample check. You're not going to go through hundreds and hundreds of VAVs, terminal units, trying to commission all those in person. One of the things I love about analytics is that you quickly are able to do that from high level over a few hours and flag exactly what units you have out here that are constantly supplying higher temperature than what they're supposed to. We had figured out issues with specific rooms where the sequence between your VAV reheat valve wasn't set up properly with your perimeter heating valve, and those were completely missed because of random sampling checks. And you never figure that out without analytics. And you also have problems where there are simultaneous heating and cooling in spaces where it doesn't really make sense. Some spaces are trying to cool, other places are trying to heat, and they're fighting with each other at the same time. So this was, like I said, an exercise that we didn't plan for, that it just came up last minute just through us trying to scramble and find out a way just to save our behind with the energy target that we have in here. But we had some valuable lessons learned from this project that I wanted to share with everyone. If anyone's interested, especially in a new construction, to deploy any sort of analytics, you got to plan in advance. Procurement, delivery, making sure the network is on, coordination between BAS, metering, everything, the communication to the servers, all of these needs to be done during the pursuit stage, design stage for sure, but even pursuit stage. Including all of these activities into your commissioning schedule is important. People need to get out of the mentality that, hey, I'm just turning on my unit and after that I'm done. No, everything's tied in together. You're working on one giant system, one building, you're handling this over to the owners, and you need to make sure all of this is working. You need to include the trades, the consultants in the very early discussions. The consultants need to understand that there are tools to help them get this information. The trades need to understand that there are tools also to verify some of this information for them. It's not always working against them. Sometimes it's helping them to give them that extra ability to, instead of running around an entire building and checking every single VAV for leaky ducts, maybe you can pick out 10 VAVs that are not meeting their set points and just work on those. That's an amazing amount of time on projects that are tight on schedule that needs to be finished. And finally, is commissioning activities need to be coordinated with your data analytics. If you have a commissioning agent that you enjoy working with and they can give you everything they need, but they're not qualified to work on data analytics, I would always recommend is that hire another consultant that can do this work and put them as a sub under your commissioning authority. This is an approach that we're currently considering on some of our other projects, and it's getting to be very helpful because we can now we're working with them to get your functional test scripts that are on paper that are going to be done during regular construction with the physical checks, translate it into digital commissioning, and just have quick checks in terms of fault detection. Hand that over to the ownership side of things. I think, Trevor, that was it.
Perfect. So now I think it's time for us to roll into the meat of this conversation, which is going to be, we'll start with an open panel discussion here, just talking about a few of these things. And so, Saeid, you bring up the idea that you need to have the consultants coordinated within the domains. Like you have a consultant for commissioning, they have to coordinate with the consultant for analytics if they're not one and the same. So that specialization is very important. But that to me seems like a drawback. Troy, you're talking about the lack of abstraction in building systems, and we have to be able to model these things. But most of as you were pointing out, most of the existing BMSs don't support that kind of, inherent modeling. And Pete, you were talking about losing a champion. Again, this is a people problem in buildings, but champions go. You have to put your eggs in different baskets, and do the use cases not speak for themselves? I suppose what I'm asking here is, given the people and the technology that we have today, what's really holding us back, and where is the bottleneck in terms of actionability on both sides, both the technology and on the people?
You want to, take that, Pete. I see it coming off your lips. I'll come from the technology point of view.
Yeah, and as you've probably seen in this, everyone out there, all of us come from very different sides. I think probably Gabe and Saeid come a little closer together, and Troy, your mind probably. I'm as you were talking, I'm thinking Russell Crowe and Beautiful Mind, because I'm not even able to follow everything that you're thinking about, but your points are very salient. The way I look at it right now, there is a lot of great technology, and I love using the whole like VHS and Betamax kind of discussion here. There's some really, really amazing technology out there, but the world we live in is so weirdly locked down, and everyone has their little fiefdoms they work in. The best technologies do not always win. Just like, again, VHS and Betamax, they don't always win. And so when the best technologies don't win, what do we have to rely back on? It goes back to the people and the processes, and the setting the expectations and the planning and all of that. So right now, there are great technologies out there for getting us a certain amount of the way there, but I don't think there's been enough adoptable technology to get us all the way without the people side of it. I am a true believer in what Troy is talking about. We as an organization have worked with not inherent third-party AI applications, but, or I said not inherent third-party, but excuse me, not inherent AI, but third-party AI that sits on top. And I'm a firm believer, if we can get cars to drive through a city, even though Troy, you kind of made me think a little bit different about that, we can get cars to drive through a city, we can have AI and different technology operate buildings better. We're just not all the way there yet. So I think we're at the point where we have to use the best technologies that are available, but the best processes and people and tools we have for managing it as well at the same time. I don't think we have the technology quite yet to just basically eliminate the human element yet.
But I guess to see it like, I'm going to reframe that just a little bit, because I'd say the problem is that too much of the industry is VHS via Betamax, and like, who cares? We want 4K streaming from Netflix, right? Like, we're literally 20, 30, 40 years off the mark on technology, and that's what matters. So that's the technology part, but you're absolutely right. Unless we bring that technology to the people, make it human scale, it doesn't matter. And I think that's the fundamental problem in this industry, is that none of the things we become used to in our personal lives, these things that a 1-year-old can use, have been applied to our industry. And it's not about necessarily making it easy for novices. We do want to do that because every one of you, I'm sure, is constrained in your business on the talent you can hire. And for every guy who can commission and program and controls system, there's probably 500 competent HVAC technicians out there. And so how do we put them more to work? How do we use technology to make people, give them the things they need while making experts more expert at the same time?
Well, how do you do that? I mean, let's not pontificate about it. What's the concrete solution here? Like, what are steps we can take in that direction, right? Like, yes, it's the good
From
technology.
our point of view is it wipe the slate clean, start over with a new workflow, right? Because if we're all sitting there trying to do analytics from like backnet addresses, like, I mean, that's as ridiculous as it seems, with no levels of abstraction between those two, we're all screwed. So let's reframe the problem to how we like think of the workflow so that you guys are all several times faster than you would be in the conventional way, and you have no barrier to why you would adopt new technology, because it's just better for you instantaneously. So I think from our perspective, it's how do you change those tools? How do you change the workflow to adapt and work for you, that you're drawing instead of programming, because the end results will be so much smarter and so much better.
Gabe, what do you think about this? You kind of come from a different perspective, right? Where do it however you want. I don't really care as long as I get the results I want. It seemed kind of like the thrust of what you were getting at. Don't lock people into a box they may be unfamiliar with. Let them propose their box.
I mean, I guess I'm not listening as they were talking, but I mean, I think that what I'm getting out from what Pete and Troy are talking about is, I think we're waiting for technology to get to a point where it can help us solve some of these issues. I think what I'm looking for to hopefully help us get us through this is a control systems that are able to support, how do I want to explain it? Multiple applications. I think that'll help solve a lot of things. And I see it kind of already happen with some of the control manufacturers. I mean, I spend a lot of time talking to the developers, where, like, for example, they're coming out with controllers with Docker built into it. So I think, again, if we're looking at, well, how do we allow these commissioning agents to be able to use their own tools, to be able to make our buildings smarter? I think it's going to take things like that. We're going to have controllers, I'm hoping at some point, all the way down to the VAV that can support multiple applications. So we have it running our basic HVAC, but then if I want to run some really sophisticated supporting digital twin, all this new stuff, well, I need to have another application to do that. So I think our controllers that have to get to a point where our controllers, the hardware can support the technology, that then we can do all this stuff that we think needs to be done. And I think, again, kind of trying to align with what Troy was saying, I think that kind of seems like where he's going with what he's presenting is that we just, right now, the current hardware doesn't support that. It's very simple, basic, but it's getting smarter. And I think, but we have to continue to push that and continue to get smarter and offer more tools that we're already seeing on the IT side, in the IT world. It's already there. We just have to get it incorporated into our control systems.
How is what you're specifying changing that? You have control over that. I assume that, like, you can say, like, we want the technology to be of this caliber. We don't want the Betamax. We want.
Yeah, it's tough because I think one of the biggest challenges I'm finding is I'm dealing with the construction industry. So, like, a good example is this hospital. I've had conversations with the general, and they think some of the things that I'm doing are really, I don't know the right terminology I want to use, but I've had to tell them and say, we're not building the building of tech 10 years ago. We're going to build the building of the future. If we're building the building 10 years ago, we're going to contract and go at it the way you guys want to do it. Mechanical carries controls, the electrical carries lighting. Everybody builds these siloed systems. Nothing, it doesn't communicate well. That's not where we want to go. The future is, to me, is having more universal, unified control systems, having controls that can support multiple applications. So it's really difficult, though, to get the construction industry to understand that. They continue to want to build buildings the way they've always built them. So how do you get them to change? How do you get them to embrace technology, right? So that's been my challenge with this project and most project, is getting them on board to embrace technology and say, hey, we can build a better building if we, from the get-go, design technology in the systems that are going to support what the future is going to be with technology.
If I summarize kind of the thread here, right, like, actionability is dependent on both the technology and the people that you've got. And so whatever else comes out of it, right, those pieces have to be roughly in place. But the industry as it is today is kind of hesitant to change, just a big boat to try and, steer a different direction. But what you're saying that if, for this to be really actionable, we're required to have good technology underpinning it and good people. Saeid, you were saying something very similar as well, that if you want this to be successful, you need to coordinate your commissioning and your analytics, but those are two difficult to coordinate things.
Yeah, I think it goes back into what Gabe just mentioned, is that a lot of the construction industries have their mind already made up, or they're set in their ways, and it's very hard for them to adjust and adapt to changing times. I don't blame them. Some of the guys that have been doing the same thing for 25 years and going back and it's like, all right, now you don't need to physically check something here. Look at these trends and tell me if something's working properly. They'll freak out, or sometimes they can't even accept it, because unless you go in and you physically see something, how do you know if it's actually working properly, right? And I get that question all the time, and trying to argue with that mentality that you have a system. It's like you have metrics that you can analyze, you have KPIs, you can go through that. It kind of gives you what you're exactly looking for, because that's what you're getting charged exactly. You're not getting charged on something opening and closing. You're getting charged based on your readings and set points and values. But it's to me, it feels like if we, I guess, try and go too focused in terms of the technology that needs to be specified in the building, it also limits the options that you're going to be able to get as an owner. Like, for example, this project that we talked about, if we had specific criteria in terms of you have to use this software, you have to use this type of thing, you have to use this type of thing, this would have taken significantly longer to try to plan out, set out, and it would have eliminated us creating something very quickly, effectively, and as simple as possible. And even though this is not something that was required by the project, even though this analytics dashboard that we created, this program that we created, it wasn't part of the PA. We've already had discussions with the hospital's facilities department. We're telling them, this is what we're doing. You're more than welcome to take it over. We know you don't have to, but we can hand it to you. And there's already talks about taking that over and using it instead of their typical software that they have in the background that they've used for other facilities.
But how are they, so, and I'm going to open this back up to everybody here because I'm interested to know. It sounds like we're all in agreement that the industry is kind of stuck in its ways, and that it's a little bit hopeless in some ways to try and drag them towards the future. But we realize that we have to, in order, and it sounds like a little bit of what Saeid you're saying is that, like, don't worry about dragging them into the future, right? Just like let them do what they're going to do, and we'll come in at the end and we're going to add this MVP, this minimally viable thing on top of it that's lightweight enough that we can afford to do it at the very end and still get what we want to get.
But let me challenge that a little bit, because when we started, we had this thesis, because it's the conventional wisdom. Buildings are full of contractors who are super conservative and don't want to change. That's the conventional wisdom. And we had that in our mind as well. Say, hey, look, we know that the industry is right now dealing with, somewhere around a dozen different controller manufacturers, and pound for pound, they're all about the same thing with a little feature this way or that way, right? And so long as we're stuck there, right? Like, we've got to get out of that mode. And what I found when we started going out to contractors and installers and HVAC mechanical firms is that wasn't true at all. They were dying to switch to something that actually solved their problems. They know what 2022 looks like. They have it in their pocket. They go to work every day and it's 1985 all over again, and they're kind of frustrated about it. But none of the other manufacturers, because the perception that we're conservative, have decided to put any effort into R&D to give people something that's meaningfully different, right? Here's Betamax. Well, it was, I got a few more pixels. Who cares, right? So I think the real problem is just we're not building solutions for the people who are the de facto customers. It's like you guys, right? You guys are the de facto customers, and nobody's really built solutions that matter, that really change the game. And we think that's really the problem, not that people are conservative. People aren't conservative. They're just not going to switch to something that's not meaningfully different.
I just wanted, Troy, I think you're spot on. And I think of this group, I think I'm the only one that is actually on the contracting side. As I mentioned, our core business is as a controls contractor, and we have a couple of different products lines that we work with. But the reason why we have a couple different product lines that we work with is not because one is noticeably better than the other, or one is noticeably different price points. There's some differences here and there, but it really, we changed because of, it was supply chain issues. That's what forced our hands. We have yet to see something come out that has been that, oh my God, moment where it's like, we're going to change everything we do. And as a contractor, we are built for efficiencies. We do things, this is how we do things. These are the standards we have. This is how we go about from sales to operations to service. And until someone does, like you said, brings that aha moment to say, hey, this is the product that's going to effectively change how you do things, nothing is probably going to have major changes. And what you brought up is actually the biggest issue, or a couple different people. It's hard to find quality people that can do the work that we all collectively do. And when you do find those people, and if they're young, training them, and then the ramp up time it takes years and years and years to get someone to where you can just hand a project to and work with. So it's really interesting, and I had a little bit of a light bulb moment. Thank you, Troy. I appreciate that. We are effectively, we are victims of our own, I don't know if it's success, but we continue doing the same thing over and over again because, that's the products and the technology that we have in front of us. We have moved away from some of that when I'm not thinking about parts and pieces, when I'm thinking more about systems and the data of the systems. I don't care where the data comes from in those widgets. Then we kind of start using some of the technologies to better understand how things are working and find issues. So that's why I think Trevor, you kind of mentioned it for Saeid. It's like, because the industry is not changing, you found your own niche saying, hey, we're going to build this to make us work better. And so, but the problem is that is outside of the general build of the building. It's like, it's a one more bolt-on. There's so many bolt-ons that people use. But we're doing what we can within the niches that we work within. So I guess until the technology, which obviously it can be there, until it's more broadly accepted or used or seen or gives people that aha moment to do things differently, I think what we're going to be seeing is these little niches of, Saeid, him building his commissioning tool for this project, me adding analytics as a third party on top of this other control system over there. Gabe, you're building your data lake because you need to do these things because the inherent technology may not be there in the system itself. So you're doing it kind of outside some of these systems.
Well, it seems to me like what you're doing, Pete, what you're doing, Saeid, what everyone in this industry is doing is developing in their own little silo, and they're not sharing. And so, like, it's in my mind, I've always been of the opinion that the analytics they should come for free if you're doing the rest of your stuff right. And Troy, it sounds like you kind of have a similar philosophy, right? Like the analytics are just like, that's the gravy, that's not the thing itself. But it doesn't seem like the industry wants to move that way. It seems to me like these are going to remain silos for the foreseeable future. Are you starting to see those break down, or are you starting to see collaboration with others that maybe have not been as collaborative in the past? I'm thinking in terms of like big controls, big, construction, that sort of thing.
Well, I think one of the things that's important to recognize about our industry is that we have a few ingredients that actually make it very possible to de-silo. And one of them is the success of BACnet. And so you've got a interface that is, near becoming the standard. That's kind of rare. So now you've got this interface point by which you can have the generic part, and then you can have these innovative parts that interface around, whether it's BACnet or one KNX or Bluetooth mesh or whatnot, having these common pieces and these innovative pieces. And I think the other one that's been brought up a few times is digital twins. It's digital twins is another place that if we can get commonality around, we can all win as an industry, because then you don't have to go invent your own one-off data lake.
Yeah, I can add a little bit to that. I think one of my focuses has been the siloed systems we see during construction, right? Like we talked about lighting, HVAC, and window shades. And I think particularly for this new hospital project, but I've been trying to work on other projects to see how I can break that down when I look at lighting particularly, lighting is very frustrating. And I'm not the only owner operator who would express that. I think we all see that the challenges with that. Lights, should be a commodity, right? They shouldn't be a proprietary device. And so, I think we keep seeing the lighting industry push that out because they want to own it. So, I know for the NHPH project, that is one of my goals. Additional goals that I have is to see if I can break that down, to push out more of a unified approach. Now, again, the unified approach doesn't work for everything. Security in our organization is a very separate thing. We're not going to incorporate that. Fire, it's a separate department. We're not going to incorporate that. But why couldn't we look at lighting and window shades? We shouldn't have multiple devices and controllers built into a building. It's not a sustainable model. It's not sustainable for just due to the fact that we just have all this extra stuff that we're putting in that eventually is going to have to be taken out at some point. It's not I don't think it's a good sustainable approach to building buildings. So I think if we can go down to the bottom there, and that's where I look, going down from the bottom up, trying to figure out how I can get these systems from at the very lowest level to work together, to talk together. I think that's just going to make it easier as we start building on top of that. It's going to be easier to integrate to a data lake, or integrate to analytics, or integrate to a digital twin. It's going to become that much easier if we start at the bottom level. But if we start out and we've already got 10 different silos of control systems, well, we've lost half the battle right there. I mean, I think if you've done that work of integrating and mapping, you know how difficult it is, for one, to do that work, and then two, try maintaining it. I mean, I've been maintaining, I've over my career, I've probably maintained 30, 40 million square footage of buildings. I haven't seen one that's lasted probably over 5 years. The integration eventually breaks. So it's a failed design. It's a failed work that gets done out of projects. So I'm determined to fix that in my career. So I think, again, we got to go down to the bottom, the construction, right at the construction level, and tackle why it is we keep getting given these siloed systems and figure out a better way to do it.
So what are we going to do about it? I mean, like you said in a little bit of the driver's seat, right, Gabe? Like in terms of like interoperability, being able to specify that at the initial onset of construction or of design. Like what practical steps can somebody take that move us in, maybe not all the way, but at least in the right direction?
I mean, I think so. For this project, what we've done, I think, again, is I think we've realized we really got to get the construction team engaged to understand that technology needs to be designed, coordinated, and installed just like mechanical, electrical, windows, all the other stuff. It has to be focused in on that way. So for this project, what we've done is we're gonna bring in what we're terming as a master systems planner. So I know there's the MSI, and that's kind of a thing right now, but I think when you go to construction teams and these groups that like in this case, we have a group that manages project. For us to be able to sell that, we had to explain to them why it is, all the things that we're talking about. I had to explain that to them and see the need of why we need to hire this MSP. So we were able to sell that, and the goal is for this consultant to help support the design of controls, to help to support and recommend the protocols, the databases, all the stuff, all the technology within the building. So it's all going to fall into them. So I really feel like this is a first step in the construction industry that I think if every construction project can go in and say, okay, who's going to be our MSP? Who's going to be designing our technology for this building? I think that would be a huge thing. I think that would help solve a lot of issues.
Gabe, I just want to say that is so required and necessary, because when you look at where buildings get designed, and you were talking about the lighting system, the lighting control system, well, that gets designed under the electrical contractor, and the controls gets designed under the mechanical consultant, and they're obviously very, very smart people, but they live within that little world that they live in, and they're not necessarily even hired, so it's not even part of their purview to think about that bigger picture and how this whole interoperability and bigger vision takes place. So I think that's a great point, having someone that's dedicated to doing that work. So thanks for bringing that up.
Saeid, I'm going to toss it to you as well, because I'm interested to know, because I think from like the commissioning perspective, you're often pinched like controls at the very end of a project, right? And there's not going to be a whole lot of leeway in terms of timing and like, oh, it's okay, we can be a month behind schedule because we got to have the analytics set up as well, right? Like I think it's wishful thinking at this point. And what are we starting to turn a corner? Is that going to become as common as the commissioning process itself, as necessary as the setup of control system?
I mean, there are a few large complex projects that we're already working on, and we're seeing that requirements stated in there. And, the owners are already saying, hey, this performance review, they call it by different things, acceptance phase, performance review, testing phase, whatever they're putting it in, just essentially the analytics side of things is supposed to be 6 months before completion of the project. And you have to have this data, and it doesn't include seasonal testing, and all those activities are extra. And so they're trying to enforce it, but the problem does become when you start adding in all those timelines together. It doesn't really leave a whole lot of time for actual construction. So there still needs to be a building that goes up for us to have these analytics in there. So I think it goes back into us having realistic expectations. I think Gabe's project where he's saying that it's going to be done in 10 years time or 8 years time is a perfect example of that. If you want to include all these activities, it's completely doable, but the expectations got to be that it's going to take that much time. It's not going to be done in 4 years and you're going to be finished. And at the same time, like Pete's point is that you still need champions in each organization to push for these activities and for these needs. And unfortunately, right now for our organization, that's me that's pushing back on, hey, you can't cut down a 9-month commissioning process down to 3 months. It's just not doable. You have all these needs, and the only way I can think of making this work is that understanding that a building can be occupied, it's safe, it can be started working once the physical checks are done, but that analytics side, that acceptance ties, that performance side of things can be done after acceptance. And it's even better if that's done that way, because the building's occupied, there's actual load, and there's going to be contractual obligations from the trades, the contractors to be involved and do the work. But that aspect of things doesn't always work because owners don't want to give control to trades on their building, right? They want to have a building that's completely done. They go in and say, all right, leave, and you only come back when we tell you for warranty issues. So it's one of those things is that either there's got to be enough time allocated to the length of the entire project, or there's got to be an understanding that, hey, performance side, it can be, but that true performance validation can be done after the building's occupied with proper load, with actual data, not all these simulations that it's being expected for us to do, and make sure it's perfectly well.
So I just want to jump on that point. The ESCO side of our business, we do so much work in the public sector, and a lot of it's K through 12 or higher education. So we're always doing that summer work, and we're always crushed at the end. And so what we are doing is exactly what Saeid's talking about, is we make sure we get the systems up and running, operational. We do our whatever functional performance testing we can do in the field, but then we make sure we have those analytics running on top of it. And because we have that M&V period, we don't treat it like warranty. And that's kind of the problem. I think we need to change our thinking. It's like, no, the project isn't done on occupancy. The project is done after you go through this entire M&V period. And it's okay that we're still out there tweaking and making changes, because we haven't seen the building operate under load. We haven't seen the building operate during this, this condition or that condition. And so what analytics give you, the ability to let the building's occupied, but we can find those issues and then address them as they come up.
I want to pivot real quick to a question that I see in the Q&A chat. And I think it's an interesting one because, there's a finite timeline to some of these things, like the construction process, the commissioning process, the initial occupancy, and so on. But Pete, particularly in the work that you're doing, and Troy, from your side as well, like that continuing engagement over the long haul, 3, 4, 5 years is really important. And to see a drop off there is really like the death knell for the program that you're working on. How do you keep excitement up for these things? How do you keep engagement high? And is it purely a new widget, the new shiny thing? How do you
from our point of view, and like to us, digital twins are today. That all of our tools, all of our automation boxes, they run purely on digital twins. And so digital twins, now we need to disambiguate digital twins a little bit. So we use what we made an open standard, the quantum digital twin standard, which is what we call an existential digital twin. It understands the underlying physics behind things. Well, as long as it's not violating the rules of physics, it can be described in quantum, right? And so that's really important because that's kind of everything we're going to see in and around a building. And that gives us continuity both to the future and across the whole process. What are we doing when we're designing? We're designing around the physics of the thermodynamics of the building. What are we doing when we're commissioning? We're validating the thermodynamics of all of the systems and the building. What are we doing as we're operating and maintaining that building? Well, we're showing those thermodynamics and all of these other different physical aspects in terms of not analytics, but the analysis of what's actually happening in this space. So to us, this digital twin is the desilification of not just what's on site, but across time in the workflow, across all these different actors in the building. And so to us, that's the key part. And then building the tooling and the features around, well, let's now process digital twins.
I'm going to take a slightly different approach to that. And again, I'm typically working with the technology that's handed to me. But as far as I think the question was, how do you maintain engagement when you're doing this type of work? And we've had customers that we've been doing this type of work, this ongoing commissioning, if you will, this machine-based commission, whatever you want to call it, for probably 5 years, and we continue to do the work. And really what it comes down to is trying to show the value in the technology and the process. And what that has tended to mean, once we get the building where we feel like it's okay, we're operating great, buildings, they just change over time. They're not static. And if we constantly are finding valuable issues and not fire hose, but here's 10 issues we want you to look into this month. Okay, next month, here's 10 more issues. And you keep the stream of issues to continue to improve the building. That's how you keep people engaged. If you start not finding much value, then maybe that's the time to back off. And instead of meeting with the person monthly, maybe it drops to quarterly. And then what happens? You drop to quarterly, you start seeing the building performance maybe degrade a little bit, then you bump it up to monthly. So it's about showing value with the tool and making sure that they can see the value in the tool. That's where we engagement.
I want to follow up on that just real quick, because there's a difference between like energy reduction and avoided cost, right? And so when you make that transition from I've gone through and said I've saved 10% of my building's energy, but now to maintain that 10% in perpetuity, I've got to continue doing some amount of work, but I'm no longer saving anything at the meter. Now it's all just maintenance.
And more like, whose value, right? I think it has to be everybody's value, because if it's just energy efficiency, that may be abstracted from the maintenance guy who doesn't care, right? He wants his job to be easier.
So breadth of use case, and
you have to bring something for everybody, right? For them to engage.
Very good point. So we're about to the end of our session here, and I think that what we'll do to close it out is I'll go back to each one of you, give you maybe 30 seconds to give your final thoughts, maybe on what you're most excited about, or what you think that this audience should know about actionability, and maybe what the single thing that they can take away from this is to improve actionability within their own deployments or within their own scopes. So Saeid, let's start with you.
I guess I'm really interested in the work that Gabe's doing in terms of the requirements and the standards and specifications that's going to be set out on future projects, especially with regards to analytics, actionable measures that we can take from data, and how we can, I guess, based on those with Troy and Pete, how our industries can bridge that gap and bring that vision into it. From what I'm seeing, a lot of the new projects, like I said, they're getting more complicated and interesting, and there's a lot more stricter requirements. So that future is looking to be extremely interesting and exciting. So I can't wait to see what comes up next from this.
Cool. Let's see who's next. I think Troy, you're up.
We always love hearing these conversations because really all the things that we built have been built around who the comments we hear from installers and mechanical firms and commissioners and owners and so for us it's really fun to take all of that and reimagine how we're going to do this in the future as an industry. I'm looking for the next year that we've got a dozen new products that are slated to release to general public from beta today over the next year. It's going to be a fun next 12 months.
Cool. Gabe?
I think I've just mainly speak to all those owners out there, people that manage facilities, just continue to demand the technology that you want. I think a little bit earlier as we were talking about how do we get things to change. Well, I think a huge part of that is if we can get enough end users, owners to demand it, the industry will listen. And if we don't demand it, they won't listen. So I think we have to continue to write it in our specifications, be willing to meet with manufacturers, developers. I do it all the time. I consider it part of my work. And I demand these things. When I want to see something, I'll ask them and I'll keep asking until I see it. So I think if we get enough voices out there demanding better technology for our buildings, hopefully we'll be able to see more of it.
Pete?
As someone who works primarily in the built environment, I am super excited to see a lot of the technologies that we talk about today catching up. So when I go into an existing building, they already have a data lake or something like that. That'd be amazing. But considering I don't work in that environment quite yet, and the buildings haven't caught up, I'm going to go back to what I said before. A lot of these tools and applications can be used at smaller and different scales. But the key is making sure that the people, the processes, and the planning are all put in place, and having that champion internal. Because if you don't have that, there's a greater chance for not achieving the success you're looking for.
Well, thank you everyone for joining. Appreciate you coming out to this session. And have a great rest of your day. And we'll see you all tomorrow.
Thank you
so
all.
much.
Take care, everybody.
Thanks.